Have you ever wondered how the very first magnets were discovered? Pause for a moment and let your imagination wander to the ancient times. Picture these sun-baked landscapes of Magnesia, a region in what is now modern-day Turkey. Here, the Greeks stumbled upon peculiar stones with an uncanny ability to attract iron. These stones, known as lodestones, were naturally occurring magnets. Imagine the fascination and awe of these ancient people as they watched these stones mysteriously draw iron objects towards them. The Greek word for magnesia, magnes lithos, eventually gave birth to the term magnet. These lodestones were not just curiosities, but tools. The earliest mariners used these natural magnets to create the first compasses, guiding their voyages and shaping the course of exploration and discovery. So the discovery of these mysteriously attractive stones marked the beginning of the magnetic journey, a journey that would lead us to understand and harness the invisible forces that shape our world. But what exactly is a magnet, and why is it attracted to certain objects? Well, let's dive into the fascinating world of magnetism. A magnet, in its simplest form, is an object that produces a magnetic field. This field is invisible, but it's responsible for the most notable property of a magnet: the force that pulls on other ferromagnetic materials, like iron, and attracts or repels other magnets. Magnetism is all about poles. Every magnet has two poles, north and south. Like poles repel each other, while opposite poles attract. This is why, if you've ever played with magnets, you would have noticed that it's impossible to push the same poles together. They'll always push away. This understanding of magnetism didn't happen overnight, though. It took years of scientific exploration and many experiments to come to this conclusion, and our understanding continues to evolve even today. So, magnets are not just mysterious stones, they follow specific scientific principles. Now that we know what magnets are, how do they fit into our modern world? Magnets are no longer just for sticking things to your fridge. They are at the core of some of our most significant scientific advancements. One of the most prevalent uses of magnets in science today is in data storage. Devices like hard drives use tiny magnetic fields to store vast amounts of data, from your favorite photos to the codes that run our digital world. Next, let's venture into the world of medicine. Magnetic resonance imaging, or MRI, uses powerful magnets to generate detailed images of the human body, helping doctors diagnose and treat illnesses. Finally, magnets have revolutionized transportation. Maglev trains, short for magnetic levitation, float above the tracks using strong magnetic fields, reducing friction and enabling blistering speeds. In essence, magnets have transformed the way we store data, diagnose illnesses, and even travel. But did you know that magnetic fields can also influence humans and other living organisms? It's an intriguing thought, isn't it? Various studies have shown that magnetic fields can have profound effects on biological systems. For instance, certain animals such as birds and sea turtles use the Earth's magnetic field to navigate during their long-distance migrations. This astonishing behavior, known as magnetoreception, is still a topic of ongoing research. But it's not just animals. Some studies suggest that even human cells could be sensitive to magnetic fields. While the implications of this are still being explored, it hints at a deep, hidden connection between life and the magnetic forces that permeate our world. And what about the Earth's magnetic field itself? This invisible shield not only protects us from harmful solar radiation, but also plays a crucial role in our planet's climate and weather systems. Magnetic fields then connect us to the world in ways we're just beginning to understand. So what does the future hold for magnetic science? We are on the threshold of some truly exciting developments. Scientists are now exploring the concept of magnetic monopolies, theoretical particles with just one magnetic pole, a north without a south, or vice versa. If found, these could completely revolutionize our understanding of magnetism. And that's not all. Magnets are also playing a pivotal role in renewable energy technologies. For instance, in wind turbines, powerful magnets are used to convert wind energy into electricity. Similarly, magnetic fields are being harnessed to control the plasma in fusion reactors, a potential source of virtually unlimited clean energy. As we push the boundaries of magnetic science, we're not just rewriting textbooks, we're reshaping the world, from how we generate power to how we understand the universe. As we continue to explore and understand magnets, who knows what magnetic marvels the future might unveil? The possibilities are as infinite as our curiosity.